To start off the next unit, I want us to look at this getting started page. So on this page is going to be a bit of a refresher of trigonometry that you did in grade 10 essential math as well as in grade 9. So we need to remember the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Now the most important thing about that formula is knowing which side is c. So remember, the side that you label C has to be the hypotenuse. So we can see the hypotenuse in this triangle. Now the hypotenuse is the longest side of the triangle. But another way we can determine what the hypotenuse is by looking for the right angle and then going for the side that is directly across from the right angle. So that one will always be the hypotenuse. So in the first example, there's just a couple questions as a refresher of Pythagorean theorem. I'm going to leave 1A for you to do on your own. In 1A, they give you this triangle here, and then they're using Pythagorean theorem, so a squared plus b squared is equal to c squared in order to solve for the missing side. So in this case, the missing side is actually side C, and we know that because it's across from that right angle. So then what they did was they labeled the other two sides A and B. So they labeled this one A and this one B, but really it doesn't matter which one you label which. And then they plugged the numbers into the formula. So then your next step would be to square both of these numbers. So you do 14 squared and you would do 22 squared to fill in these two blanks here. Now, when you get to this step, you're going to have a number centimeters squared. Now, we want to solve for just centimeters. We don't want to solve for centimeters squared. So what you're going to do to cancel out this little squared here is you want to square root this side of the equal sign. But whatever we do to one side of the equal sign, we have to do to the other side. So then when we square root this side of the equal sign, we end up with just C because this cancels out this. And then on the other side of the equal sign, you're just going to square root that number that you would have in this blank. So I'll upload the answer key so that you can look and check your work, but make sure you are comfortable doing that. And then in part B, this time they gave you side C. So you'll notice that this is the hypotenuse over here. So that's side C. And then we are solving for side B up here. We don't know what it is. And again, they're using the Pythagorean theorem, a squared plus b squared is equal to c squared, and they plugged in the numbers that they had. Now, in this second step, you'll notice that this 9 squared isn't here anymore. And that is because they were trying to get the b all by itself, because in this case, we need to solve for b. So eventually, we need the b to be all by itself on one side of the equal sign. So what they did was they took this and they moved it to the other side of the equal sign, like that. Now, when you move a term to the other side of the equal sign, what happens is that you do the opposite sign of what it is over here. So on this side of the equal sign, there's an invisible plus sign over here. It's a positive 9.0 inches squared. So when they move that to the other side of the equal sign, they then change it to a minus 9.0 inches squared. So now the b term is all by itself, and now the steps are basically the same as this first example. So then we would square both of the numbers, so 25 squared, and then you would subtract 9 squared from that. And then in this step, you would have to square root both sides of the equal sign. So if you need any help on that, please let me know. And then in the next example is where we are looking at SOHCAHTOA again, and hopefully that rings a bell from grade 10. SOHCAHTOA is an acronym for the trig ratios. So what they do is they help us come up with the equation to use for each sine, cosine, and tangent. So starting with S stands for sine. So sine of an angle, so I'm just using the letter A for angle, is equal to, and the O stands for opposite, and the H stands for hypotenuse. So the sine of an angle is equal to opposite over hypotenuse. So that's where we get that acronym SO from, S-O-H. And then K, the C stands for cosine, so cos of an angle. And then the A is adjacent, and the H is hypotenuse. And then TOA, we have T stands for tangent of an angle is equal to, then the O is opposite, and the A is adjacent. So now when we're dealing with this question, we're going to use SOHCAHTOA to help us come up with these trig ratios. So let's just look at A together. We have the sine of A is equal to 3 over 5. So to start that example, we're going to place a little marker on the A angle, and then we know that the sine is equal to opposite over hypotenuse. We know that from our SO acronym. So then they have the sine of A is equal to, then the opposite side from A is 3, because that's right across from A, that's the opposite side. So that's how they got the 3 up here. And then the hypotenuse is always right across from that right angle. So the hypotenuse is 5, so that's how they got the 5 on the bottom. So the sine of A is equal to 3 over 5, and if we were to change that to a decimal, we would put 3 divided by 5 in our calculators, and we would get 0.6. So now let's try B together. The cos of A is equal to what? So I'm going to put a little angle on A, and now using SOHCAHTOA, we know that the cos of A, or the cos of any angle, is equal to adjacent over hypotenuse. That's where the A and the H come from, adjacent over hypotenuse. So the adjacent side to A is the side that's right beside A that isn't the hypotenuse. So this side right down here is right beside A, and it's not the hypotenuse. So this would be the adjacent side. So I'm going to put 4. And then the hypotenuse, once again, would be the same side as before, the 5. So the cos of A is equal to 4 over 5, or in other words, 0.8, if we were to convert that into a decimal. So I'm going to leave the other ones for you to try, but please try them and let me know if you need any help getting a little bit of a refresher on SOHCAHTOA. In question 3 and 4, you're going to need to use your calculator, and this is just to check to make sure that your calculator is working properly, and you're going to need it to work properly for this unit. So on your calculator, make sure that you have a little degree symbol on it somewhere. So it should be either say deg, D-E-G, or a little d. It needs to be in this degree mode, or else your answers will all be incorrect. So then in example 3, we just need to calculate these things. So just get some practice plugging these in your calculator. So 4 times the sine of 25. So if you put that in correctly, you should get 1.690, and that'll just keep on going. And then for B, if you do 16 divided by the cos of 56, you should get 28.612. So please try this in your calculator to make sure you know how to enter it correctly. And then in 4, this time we are solving for an angle. So you'll notice that this spot right here has a letter now, and it doesn't have a degrees like the question did up here. See how these ones had degrees there? Now we just have some letters, so we're going to have to solve for the angle. But whenever we solve for the angle, we have to use the inverse buttons. Now, what the inverse buttons are the ones that look like this. So in order to access them, you're probably going to have to press the second key on your calculator. It'll either say second or it'll say shift. And these buttons will be right above your regular sine and cosine buttons. So here I pulled up a picture of a scientific calculator, and you can see the sine, cosine, and tangent buttons on it. And right above those buttons in small yellowish font, it says sine and then the exponents in -1, and cos and the exponents -1. So for each of those are the inverse buttons. If you are using your phone calculator for this, you're going to have to rotate it to the side, and then when you press the second button, you'll be able to find those inverse buttons. So now I want you to practice doing inverse sine of 0.8387. Because if we have a question like this and we want to solve for this degree in here, we need to use the inverse button. So remember, if you're solving for an angle, use the inverse. So we put inverse sine of 0.8387, and we would get 57.003. So in other words, we just solved for this C in here. We just solved for the angle. So angle C, and that's what this little sign here says. That means angle. So angle C is equal to 57 degrees. And now I want you to also try plugging in B here. So the inverse tan of 7 over 3, if you were to put that in your calculator, you would do inverse tan button and then 7 divided by 3. Now keep in mind that some calculators you might have to do the 7 divided by 3 first and then hit the inverse tan button. It depends on the calculator you have, so make sure you know how to use your calculators. So then if you plug this in correctly, the inverse tan of 7 over 3, you should get 66.801. So therefore, angle F, which is what we're solving for here, that's why we had to use this inverse button, angle F is equal to 67 degrees. So then please try example 5. I will upload the answer key so you could check your answers, but in these ones we're just solving for an unknown side. So then you have to decide what trig ratio to use, but actually they gave you which trig ratios to use. So this one, they chose sine because they give us this angle, they give us angle B. So we're going to start from working at that angle. And we need to find this side over there. Now they give us this side, so from angle B, this side is considered the hypotenuse, and this side that we're looking for is considered the opposite side. So then you see we are dealing with the hypotenuse and the opposite. So if we're following SOHCAHTOA, which acronym has the opposite and the hypotenuse in it, or in other words, which acronym has O and an H in it? Well, that would be this one right there, has an O and an H. So because of that, we know we're going to use sine. So that's why they chose to use sine over here. So they put the sine of 55 degrees, because we have that degree, is equal to opposite over hypotenuse. Now the opposite side we don't have, so they just labeled it CA. So this just means the side between the angles C and A. That's this side right there. But the hypotenuse we do have. They gave us 5.7 for the hypotenuse. Now our goal is to isolate CA because that's what we're solving for. We're solving for the length of side CA. So in order to isolate CA, we need to get rid of this 5.7 underneath it. So in order to isolate CA, we need to get rid of this 5.7 that's dividing underneath it. So what we need to do in order to cancel that out is we need to do the opposite of divide by 5.7, which is multiply by 5.7. So I'm multiplying this side of the equal sign by 5.7, but that means we also have to multiply the other side of the equal sign by 5.7. So when we do that, it's canceling out this number down here, which is why we're only left with CA in the next step on that side of the equation. And then over here, we have to put 5.7. So now in your calculator, you're going to do 5.7 times sine of 55, and you should get 4.669, and that decimal will keep going. So that's the length of side CA. So CA is equal to, we'll round it to 1 decimal place, 4.7 centimeters. Now in B, we need to solve for side PQ. So that's this side. And they gave us this angle down here. So they gave us angle Q. So we're going to be working from that angle. Now, if we look at the side, we're missing this side here. We're missing the hypotenuse because it's right across from our right angle. And then they give us the side that's right beside angle Q. So that would be considered the adjacent side. So then we have to think if we're using SOHCAHTOA, which one uses A and H in it. So A for adjacent and H for hypotenuse. Well, that would be the cosine one, the ka. We have A and H. So we're going to use cosine for this question. So that's why they put the cosine of 35 is equal to adjacent over hypotenuse. That's the ka. So now let's plug in some numbers. So the cos of 35 is equal to the adjacent side, which we have 4.7, over the hypotenuse. And we don't have the hypotenuse. So what they did was they wrote PQ. So that means side PQ. So that's this side that we're missing between angle P and angle Q. So now this question's a little bit different because we need to get PQ all by itself on one side of the equal sign, but right now it's in the denominator. So what we need to do to isolate it is the first step is to multiply both sides by PQ. So I'm going to multiply both sides of my equal sign by PQ. That's going to cancel it out down there and then bring it up into the numerator on the other side of the equal sign. So now we have PQ times cos of 35 is equal to, and the only thing we're left with on this side would be the 4.7. because these PQs would have canceled out. So now we still need to get the PQ all by itself, but we have it multiplying the cos of 35. So then, in order to cancel out multiplying of cos of 35, we need to divide by the cos of 35 on both sides of the equal sign. So we divide this side by the cos of 35, which cancels that out. So that'll leave 4.7 divided by the cos of 35 on the other side, because we did divide both sides here. I just didn't write it down. There we go. So then we have PQ is equal to 4.7 divided by the cos of 35. And if you put that into your calculator, you'll get that PQ is equal to 5.737. So side PQ is equal to 5.7 centimeters. Question number 6, you don't have to worry about. We won't worry about this one, so you can cross that one out.